Yeah, we'll use this set. Now, the dot product, u dot v is equal to u1 v1 plus u2 v2 is our overall dot product. Is what we're doing. Now I'm just going to look at this just to make sure I didn't flip the signs. Yeah, u dot v is u1. Yep. Is this here. So give me the vector u. V is. So if we do this here, using these to do this here, well, u1 is going to be, so we can say 4 times 1, because we're having that first term. Because really what we're looking at for this equation is saying that u is equal to 4 comma negative 2, and v in this case is 1 comma negative 1. Now I did it this way so that we can add that I and j in. So we're really adding or multiplying those first two, 4 and 1, and adding it to, so actually we don't even need the I anymore, plus negative 2 times negative 1. Well, 4 times 1 is, negative 2 times negative 1 is. So the dot product is going to give us a number. The dot product will give us a number, which is 6. Yeah. But that's it there. Questions on this here? So we good with dot product? Because it'll work with the other one too. Okay, good. I'm always a little paranoid that this thing's not turned on. Okay, so 31 through 33, use these here to solve for each one of those. Yes. Mm-hmm.
Can we maybe look at 33?
33, yes. Let's go back up to the top. Now, u is what?
3 and 3.
3 and 3. V,
Negative 4 and then 2.
I think, is there a u or no?
W is 3 and negative 1.
Okay. So what's the problem? Okay. It's u dot v minus u dot w. So this is dot product. This is going to be dot product. And I'll make sure that's clear, especially on the test, to where if we're using multiplication, UV or parentheses, something other than the dot for multiplication. Now, u dot v is going to be 3 times plus 3 times 2 minus 3 plus W.
Yeah, it's negative 1.
So here we'd have 3 times negative 4, which would be plus negative 12 plus 6 is 9 minus 3 is negative 12. Yeah, because the dot product with 0 is still 0. All right, top of the next page. Find the angle between 2 vectors. So the angle between 2 vectors, this is going back to dot product. Because cosine of theta is equal to u dot v over the magnitude of u times the magnitude of v. And this is just our formula for the angle between 2 vectors. So if we're given u, you're good? So negative 2. We can do this here. Now cosine of theta is going to equal, well, u dot v, well, we know it's going to be 1 times 0 plus 0 times why am I just drawing a happy face? Well, it's not that it's all going to be 0. What's the numerator going to be? 0. So 0 divided by whatever this is going to be cosine of theta equals 0. Now, okay, I'm going to erase the smiley face. Because the magnitude of u is going to be the square root of, well, 1 squared plus 0 squared times the square root of 0 squared plus negative 2 squared. So this first one here is going to give us, so we would get a value for the denominator, but because the numerator is 0, the whole thing works out to be 0. And we'd have to take cosine inverse of it. Cosine inverse of 0. I'd plug it in. I want to plug it in because it's 90, yep. So this means that these angles are orthogonal, and I did not spell that right because that has a lot more letters. Orthogonal to each other. Orthogonal is O-R-T-H-O-G-O-N-A-L. Yeah, I'm definitely missing a few. So orthogonal means they're perpendicular to each other. But that's what we do with this here. So it's really utilizing that formula. Does that make sense? We good with that there? Do we have that formula written down? Okay. Yeah, because it'd be good to have some of these formulas down. Yeah, the vectors u and v are orthogonal if and only if u dot v is equal to 0, which it is here. Okay. The next 37 through 30, or 36 and 37, find u dot v where the angle and whatnot is given. Okay. I'm going to erase all of this here. Well, almost all of this here. Because what we need for these here is we're trying to find u dot v, yes? We're given the magnitude of u and the magnitude of v and an angle, yes? If only we had a formula that used two magnitudes and an angle. Okay, there we go. And really what this is we can manipulate this to say that u dot v is equal to the magnitude of u times the magnitude of v theta, because I'm just multiplying both sides by the magnitudes, which cancel out, leaving us with just the dot product, equals everything else, which makes this a little bit easier, because we'll pick one of them. Cosine of. And we get this here. Well, we can plug this onto a calculator, just make sure the calculator is in radians and not degrees, because that's going to make a little bit of a difference. 3 pi over 4, 2, square root 3 over 2, 18, whatever, let's see here, 2 carry the 7, 162 square root of 3? Or no, I might be way off.
What are we assigned to it?
Well, we're just multiplying 9 times 36 times cosine of 3 pi 4. Yep. Mm-hmm. Yep.
Do you want a positive number or negative number?
It's just going to be whatever the value is. Oh, yeah. Yeah, it didn't like... That's what I thought, yeah. So that is the correct answer. .103. These are the same thing. It just, the calculator, this got too big. Because cosine of 3 pi over 4 is negative square root 2 over 2. And then that would make 36 into 18. 9 times 18 is 162. But the calculator ran out of memory room to have negative 162 square root 2. So it converted it to a decimal, which is perfectly fine. Because as y'all know, I will take the answer in radical or decimal form. As long as it is the right answer, I don't care what form it's in. Does that make sense for this here? That'd be nice having that equation written down for that there. Any questions on any of this here? Yep. Yeah, because you just plugged in the magnitude of u times the magnitude of v times cosine of our given angle, and it gives us the answer. And make sure that's equal, cosine of theta is equal to it. Because that might be something you remember right now, but when push comes to shove, the little things always fall out. All right. Find its absolute value. I feel like the absolute value is the magnitude. Surprising how some of this stuff is just slipping at the moment. Absolute value of a complex number is equal to the distance formula. That's my point. Too far. Yep, the absolute value of a complex number is equal to the square root of a squared plus b squared. So our number is?
38.
Sure.
Minus
A and b. So the absolute value of it is going to equal the square root of 5 squared plus negative 12 squared.
So 25 and 13.
5, 12, and 13. Pythagorean's triples strike again. So that's just how that works. I mean, if we really come across any different numbers besides this, we could plug it into a calculator and exactly as you were doing. 5 squared plus 12 squared is 25 plus 144, which would give us 169. And the square root of 169 is 13. So it worked out nicely on that one. Some of them might not work as nicely as that. Like the next one, negative 8 and 3, because that would be 64 and 9, which would give us 73, which doesn't have any perfect squares. Because if we look at the perfect squares, well, first one's 4, it's not divisible by 4. Then after that is 9, it's not divisible by 9, because 9 divided by 73 would be, well, 70, gotta use all my fingers. 72 would be the closest one. Well, that would be 9 and 7. Well, the perfect square, the numbers drop lower than it, so anything else is going to be smaller, so nothing works. So it's just a square root of 73. Does that make sense? Okay. For problems 40 and 41, write each complex number in trig form. I was just looking at the second one. I was like 5 halves. Okay. Why don't we do 41? You're welcome. So to write it in trig form, we are writing it as r cosine of theta plus I sine theta. So we need r and theta are the two we need. So it might be helpful if we actually had this written out as 5 squared of 3 over 2 minus 5 halves I, because that gives us our real values of A and B. The reason I say real values of A and B, because R is equal to A squared plus B squared, and theta is equal to tangent inverse of B over A. So for us here, R is going to equal the square root of 5 squared of 3 over 2 squared minus 5 halves squared. Well, luckily, both of these are going to be over 4. 5 is going to be 25. 75. I'm going to go on and simplify the denominator because when we subtract both of these, we'll still have 4 on bottom. Square root of 4 is 2. Now on top, we have 75 minus 25, which would give us 50. Well, 50 is the same as 2 times square root of 25 is. Square root of 2 does not simplify. Yeah. 5 square root of 2 over, yeah, the square root of 2 and 2 won't simplify out because the square root of 2 is a non-repeating, non-terminating decimal. It's 1 point going on. Because it's less than 1.5. Because 15 squared is, I think, 225. Yeah.
Yep.
So 1.5 times 1.5 or 1.5 squared would be 2.25. So it's too big, so it's going to be less than that. And on a side note, because if you're doing square roots by hand or using a calculator to approximate, what you're really doing is the best method to do it is figure out the 0.5. So if I'm looking at 2, okay, I know 1, I can divide it by 1, that works. And I go to 1.5. If it's too big, I go down. If it's too small, I go up until it pops up over 2 or just below 2. And then I go to the next digit and continue the process. Tedious, yes. Okay. Now we need to find theta. Well, theta is equal to tangent inverse of negative 5/2 over 5 square root of 3 over 2. Now you can type it in just like that there. Tangent inverse, fraction on top, negative 5/2. My brain's saying negative 60 or negative pi over 3. 6, pi over 6. And the other one. Negative pi over 6. Now, because this is really, we're looking at our x and y. X is positive, y is negative, so we're technically in the correct quadrant, but we want to make it positive, so we would add what to it? 2 pi. 2 pi. So we're going one full circle all the way around. So we're taking it away from 360 essentially, or 2 pi, which would give us 11 pi over 6. Because our denominator is 6 and 2 whole ones would be 12. 6 times 2 is 12. So 12 minus 1 is 11. Stay. And what we have left is cosine of 11 pi over 6 plus I sine of 11 pi over 6 would be our overall answer. Any other questions on this here? Yes? Standard form. I actually like this. So the first one is the square root of
48 cosine of 30, negative 30. And plus sine, I sine of 30.
okay. What is cosine of negative 30? Zero point one five.
Oh, your radius.
Yep. I was like, that, I think that should come out to a whole number
I did the same thing.
or a fraction. Do the same thing for sine. Will square root of 40 simplify at all? 48? 16 plus 16 is 32, and 32 plus 16 is 48. So 16 times 3 is 48. Square root of 16 is 4. Okay, you all ready for the next part? Well, 4 square root of 3 times square root of 3. Yep, because square root of 3 times the square root of 3 is 4 times 3 is divided by 2 is, well, 4 times 1/2 would be 2 square root of 3. I want the I next to the 2. Yeah. Yeah, this is also what they call going from polar. This would be polar to rectangular form. It's just doing this here. So we're just simplifying cosine and sine for their given angle for what they are, the value that they are, and then multiplying it by the r. Yeah, no, it's a lot easier than what we think it is. Because for the longest time, I kept trying to overcomplicate this because I was keep thinking it had to be this. There had to be something more than just this, but it's literally just this. Yeah, it wasn't until I taught this for the first time in trig, I think, and I'm like, oh, it really is as simple as this. Questions on this here? Did I make it look a little bit easier than what it was? Yeah. Yeah. Okay. So product, which one do we want to look at?
U 44.
Or not R1, R2. If we have two vectors, z sub 1, z sub 2, being multiplied together, we get this here. Now, if we're dividing, so these are our two formulas. So if we're multiplying, we multiply the r's together and add the angles. If we're dividing, we divide the r's and subtract the angles. Questions on this here? We'll look at the first one. So I'm going to kind of jump into the actual writing it in the formula. So what's our first r value? and the second R value. First angle. Other angle.
Wait, no, it should be 3 pi.
Okay. Yeah. Yeah, we'll consider the first equations two angles that are both pi over 3 as still part of the first, because those angles are the same.
The R1.
Yeah. Well, 3/4 times 4 is, because the 4 and 4 would cancel. Now, there's two ways we can do the next part. I can figure out what pi over 3 plus 3 pi over 4 is, or I can go into the calculator, make sure it's in radians, and do cosine of pi over 3 plus 3 pi over 4, and type it all in. And I have a feeling y'all are going to go with option number 2. Yep. Now you can go back in there, just change it from cosine to sine, hit enter and do the same thing. And I think it's going to be, it's still going to have square root of 6 and square root of 2. Or what'd you get? Negative square root of 3 over 2. That's interesting. Yeah, I just want to look at it, see. Okay. Let's see what this value is. Or I'm just looking, because it works. Yeah, it's 4 pi over 3. That's what we're looking at. Yeah, I just find it odd that cosine came out to be that. I'm not doubting it. It seems like an odd answer. I wanted that. That's what's odd, Zach? Is if we simplify it, it gives us what? Calculator's being funny. So I would try just plugging that in first and then doing the second one, applying it to cosine. And sine doing the same thing, because I have a feeling there's some for sine that's going to do the same thing to it. Don't know why it didn't. Yep. It's really weird. And then we can just multiply through by 3, which will give us negative 3 halves plus, well, not plus, negative 3 square root of 3 over 2i. Now, I'll back up and say you can type the whole thing in and do it that way. But the reason I kind of, well, more or less balked at the answer was because, again, sine and cosine go in pairs, yes? Because normally if I get 3 square root of 2, we're looking at 1/2. If I get 1/2, square root of 3 over 2. Those two go together. We've kind of, when we looked at the unit circle, those two, if one of those showed up, the other one showed up, yes? Because if sine, if I plug in sine and get square root 2 over 2, I'm expecting cosine to be square root 2 over 2. when we did our half angles and double angles, when we got the square root of 6 plus or minus, had the square root of 6 and square root of 2 over 4 for sine, we ended up getting square root of 6 and square root of 2 over 4 with the signs different, but we got those same things on both, yes? That's why I kind of balked at it when it gave me the square root of 6 and square root of 2 over 4, but then gave me square root of 3 over 2 for sine, because they go in those kind of pairs. That's where I was looking back at it and saying, okay, I feel like this should be a little different, and it was. So if you get that kind of weird number set where one of them's not really matching up with the other, try simplifying it and see if it works out that way. Questions about division? Dividing r's and subtracting. For powers, that's dividing. That'd be our division.
Write down the equation he has here.
Yes, it would be that one. Yeah, quotient and division are the same thing. Yep, so that's all we would do for those. So we would just subtract them, subtract our, so for 46, it would be 1/2, because our value for the top is 1,
Okay.
over 2, and then we'd have cosine of 120 minus 40, plus I sine of 120 minus 40. And then we would simplify sine and cosine of 80 to get down to our answer. Is this here. Now for 49, what we would need to do is we need to convert, what is that?
3 minus 2i, 8.
So 3 minus 2i, I'm going to find r, which would be 3 squared plus negative 2 squared. Well, that would be 9 plus 4, which is the square root of 13. It doesn't reduce. Now we'll also take tangent, or theta is equal to tangent inverse of negative 2 over 3. And whatever we get, we'll add, let's use 180, or not 180, 360. Let's use degrees because it's a little bit easier to work with. And the reason I'm adding 360 is because tangent inverse is going to give us a negative angle for it. Tangent inverse of negative 2 divided by 3, which is going to be negative 33.69 if we add 360 to it. Yep. Yes. So we can add 360 to it because it is in the correct quadrant. So 326.3. Here, and then we can use this formula. Yeah, you're good. I do, because she's not here. And now to apply this, we're going to just put the 13th to the 8th. We're going to multiply this by 8. And we're going to multiply this by 8 to get our answer.